Good morning. It's May 4th, and thanks for tuning in. I just wanted to take a few minutes here and just make sure everybody's doing okay, check in, and hope my Algebra 2 class is staying strong and making sure you guys are all doing what you need to stay healthy, to make sure that you're taking care of yourselves and really making the most of this time. Some of you haven't checked in with the material and stuff lately, so I just want to encourage you to do that. And it's really important that you are kind of keeping up with the material and stuff as we go through it. Alright, so I want to take a few minutes and go over last week's assignment, Factoring Higher Polynomials, Part 2. And if you remember, this is where we now, once we pull out the greatest common factor, what's left is a quadratic, but it's not factorable, meaning we can't use the box method or any of the other methods that we typically have. To ease us through that, we actually have to use the quadratic formula. And like we said in the videos last week, that what we were going to do is we were just going to use a quadratic calculator online. So I pointed you to the quadratic calculator at Math is Fun. And I will be using that today as well to make sure that all is good with that. All right, so let's take a look at the homework. I'm going to do problems number 1 and number 2 just to kind of switch things up a little bit. And we'll switch back and forth between screens and all that stuff and hopefully give you a good idea. Remember, the idea here is by me doing these problems that you then revisit your worksheet and go over it, and if you want, resubmit it to me and go from there. All right, thanks. All right, so let's take a look here. So here we have 8x to the 4th plus 20x cubed minus 36x squared. I look at this and I see that the highest exponent here is 4. So what does that mean about my number of x-intercepts that I'm expecting? I'm expecting to see 4 x-intercepts. With regards to end behavior, I know that because it's even, that means both ends are going to be headed in the same direction, either up if the coefficient is positive or down if the coefficient is negative. It is positive, so it's actually going to be up, up. And then my y-intercept, which is 0 comma something, so if I take and actually plug in 0 into all of the terms here, I find out that the entire equation goes to 0. And so that means my y-intercept is 0. That saves me a little bit of time here. Okay, so let's look at greatest common factors. I have every term has an x, and every term has at least an x squared. So I know that I'm going to be able to pull out an x squared. And then every term is even, and every term has at least a factor of 4. So I'm going to pull that out. So that means I have 4x squared as my greatest common factor. And remember, I'm going to take that common factor and I'm going to divide each term by that. So 8 divided by 4 is 2. X to the 4th divided by x squared is x squared. 20 divided by 4 is 5. X cubed divided by x squared. Remember, we subtract exponents when dividing, so 3 minus 2 is 1. And then negative 36 divided by 4 is negative 9. X squared divided by x squared is 1. So that right there is my partially factored form for number 1. I then am going to take that and set each piece equal to 0. So we'll come back over here and we'll say, all right, 4x squared is equal to 0. Right, because now I'm looking for my x-intercepts. I want to know, where does this graph cross the x-intercept the 4 times that I had mentioned earlier. So 4x squared equals 0, divided by 4, x squared is equal to 0. Take the square root of both sides, x is going to be equal to 0. But remember, because I took the square root, that means that it is going to be a multiplicity of 0. A multiplicity of 2, which means that the graph is actually going to bounce at the x-intercept of 0. So I just need to keep that in mind as I go about checking and drawing up my graph here. The next is the 2x squared plus 5x minus 9. Now remember, we said that this quadratic is not factorable. So we're going to need to use the quadratic formula, which means we need to make sure we understand what a, b, and c are. A is the coefficient in front of the highest exponent, so that's 2. B is the middle coefficient, so that's 5. And c is going to be negative 9. So that means I'm going to go over here to my quadratic solver, and I'm going to type in 2, 5, and wow, it's still set up basically from the last example that we did. And there are my x-intercepts. Okay, so I have negative 3.7 and 1.2. So I'm going to make sure I write that down here. So I have an x-intercept of negative 3.7 and an x-intercept of 1.2. This is just an approximation. Remember, ultimately, in real life, in technology or engineering or anything like that, where we would be doing this, we'd be using some sort of graphing utility, but we want to get a rough idea of what's happening to make sure that when we do use that graphing utility, we have typed it in correctly and we know what's going to be happening and what we're expecting to see. And we know if we typed in it correctly so that we avoid getting the correct wrong answer. So I have all the information that I need right now. I know that my end behavior is up, up. I know I have a y-intercept of 0. I have an x-intercept of negative 3.7, which we'll say is right here, just short of 4, negative 4, excuse me, and just past 1 here. So I'm going to come down through that negative 3.7, come down here to some point, going to get to that 0, and remember that's a bounce. So instead of going through it, I'm going to bounce off of it, and I'm going to take a quick little bump and go back up. So there's a rough idea. A rough sketch of the graph. Again, it is not precise. We don't know what the local mins are in any of this, so we don't know how far or down, or, wherever they are exist on the graph. But we're not interested in that. We just want to get the characteristics and understand what's happening. Okay, so let's look at number 2. Number 2, 3x5 plus 9x4 minus 21x cubed. So let's go about it the same way, x to the 5. So that means I'm expecting 5 x-intercepts. So it should cross the x-axis 5 times. Now remember, that includes both throughs, meaning we have an odd root, an odd number of the root, or it could be a bounce, in that we have a multiplicity of the same root. So just keep that in mind. Our end behavior is odd, so that means the highest exponent is odd, so that means our end behavior is going to be in the opposite directions. One's up, one's down, and we need to check the lead coefficient to make sure we know which way that is. So 3 here is positive. So if I think of a positive slope, that means it's down on the left and high on the right. Okay? And just check out my y-intercept. I plug in 0 for x, 0, 0, 0. Everything zeroes out, so my y-intercept is 0. You probably have recognized that that is a pattern for what we're doing right now. Okay? So let's go after our common factors. The greatest common factor here. So x to the 5th, x to the 4th, x to the 3rd. The smallest amount of x's I have in each term is x cubed. Okay, and then I go back here, 3, 9, and 21. Well, those are all factors of 3. And since 3 is the smallest, then that's the most we can take out. So I'm going to factor out a 3x cubed out of this. So 3x5 divided by 3x cubed. 3 divided by 3 is 1. x5 divided by x cubed. And remember, when we divide exponents, we subtract. So 5 minus 3 is 2. So that gets us an x squared. 9x to the 4 divided by 3x cubed. So 9 divided by 3 is 3. x4 divided by x cubed is x. And then negative 21x cubed divided by 3x cubed. So negative 21 divided by 3 is negative 7. X cubed divided by x cubed divided by x cubed is 1. So there are our factors. 3x cubed, x squared, plus 3x minus 7. So let's go about factoring this. Okay, so 3x squared cubed, is equal to 0, because we're finding the x-intercept, so that means y equals 0. I'm going to divide by 3, x squared is equal to 0, take the square root, take the square root. X is going to be equal to 0, and again, I had to take a square root, so that means there's a multiplicity of 2, which means it's going to bounce. Okay? And then I have x squared plus 3x minus 7. So a is equal to 1, b is equal to 3, and c is equal to negative 7. So that means I come back over here to my quadratic solver, and I'm going to type in a is 1, b is 3, and c is negative 7. And I end up with negative 4.54 as one x-intercept, and 1.54 as the other x-intercept. Okay, so we can write those down in our on our sheet here. So I have x is equal to negative 4.5 and x is equal to 1.5. Now, checking to make sure that I have everything that I need here. And so I just look at this and I go, okay, I have one x-intercept, two x-intercepts, and 3, 4. But remember I said 5. So that means I made a mistake somewhere, and this is exactly why we are doing this. Alright, sorry about that. And that was my daughter. Alright, so as we were saying, we're supposed to have 5 x-intercepts, because our highest exponent, or the degree of the function, is 5, telling us that we have 5 x-intercepts. 1, 2, 3, 4, but where's 5? Well, 5 came about as an honest mistake. This exponent here was supposed to be a 3. And I wrote it as a 3, but I misread it. So that should actually be x cubed there, which means I'm taking the cube root of 0, which gives me 0 still. So that means instead of a multiplicity of 2, I have a multiplicity of 3. And instead of a bounce, that means I have a through. Okay? So that should work. I have 1, 2, 3, 4, 5. I have 5 x-intercepts. I have my y-intercept, and I have my end behavior. So let's graph this. So I know over here somewhere it's going to be down. Over here it's going to be up. It's going to cross the y-axis at the y at 0, excuse me. And I have an x-intercept at negative 4.5, which is right here, and an x-intercept at 1.5, which is right here. So it's going to go up, down through the 0, and up. So it'll look something like that. It looks absolutely horrible, but remember this is a rough graph, and we just wanted an idea of what it looks like. So hopefully from my mistake, you see the importance of making sure that everything checks out before we go ahead and graph it. Make sure that your degree, whatever the highest exponent is, matches up with the number of x-intercepts that you actually come out with. Make sure that you always have a y-intercept, and make sure that you have figured out what your end behavior looks like. Okay? Any questions? Don't forget, you can always send me a text through Remind or whatever the case is and let me know, and I will get back to you as soon as I can. Tomorrow's video, we're going to be switching gears. We're going to be leaving polynomials, and we're going to go on to exponential functions and logarithms, and probably finish out the year on that topic. So we'll see how that goes. All right? Thanks for watching, and take care, stay safe, and I will see you again tomorrow.